Hi, good morning everyone. Today I am going to walk you through the steps that are involved in using a NTC thermistor, that is a negative temperature coefficient thermistor, in using it to determine the temperature. So first let's start with the circuit layout for the problem. So it's a pretty straightforward circuit. The elements of the system are Arduino Uno microcontroller board, a 16x2 LCD with I2C module, and a thermistor. Thermistor is basically a temperature sensor whose resistance changes with temperature. It's not a simple linear relation, it's quite complicated. Nonetheless, there is a relation between temperature and the resistance. We are going to use a voltage divider circuit to determine the resistance. The way that would happen is as follows. We are going to use the 5-volt output from the Arduino, and we are going to apply that across a known resistor in series with the thermistor. So this is 5-volt and this is ground. I presume that you have watched the video on the load cell where I have described in detail as to the features of the Arduino Uno board as well as that of the breadboard and the LCD module. So I'm not going to repeat all of this once again. So once we apply 5-volt across this series resistance system, then we extract the voltage across the thermistor and we connect it to the analog pin A0. Arduino Uno uses a 10-bit ADC. So when you read the voltage from A0, you are going to get an integer value between 0 and 1023. Please note that 2 to the power 10 is 1024. So once you read the voltage across the thermistor, you can divide it with the current within the circuit in order to get the resistance of the thermistor, and this resistance value is displayed in the LCD module as well as on the serial monitor. So the LCD module is also powered with the 5-volt from the Arduino board. The serial clock from the LCD module is connected to pin A5, and the serial data from LCD module is connected to A4. Next, let us look at the code for this particular problem. So there will be two programs which we will be using: the thermistor resistance measurement, and the second one is temperature estimation using the coefficients. So in order to use this particular code, you should have basically connected to the appropriate communications port. So in this case, COM5 is the Arduino port, it's already selected. The board must be the Arduino Uno board, and amongst the libraries you should have already installed this liquid crystal I2C library. Now once you have done all of these things, then we first set the address of the LCD display. Then we define that the analog pin in this case is A0, and the applied voltage across the series circuit is 5-volt, and the fixed resistor we are using in the circuit is 80 kilo ohms. Now so there are two functions in the program: void setup and void loop. The void setup runs only once, void loop is continuously executed. When we are doing serial communication with the computer, we set the baud rate as 9600. Please remember that the baud rate in the Arduino and in the serial monitor has to be the same. Now in the void loop we are reading this analog pin voltage, and then based on that we determine the voltage across the fixed resistor and compute the current within the circuit, and the voltage across the thermistor divided by the fixed current gives you the resistance of the thermistor. Once we get the resistor, we use the serial print command to print it on the serial monitor, and we use these commands to print it on the LCD screen. So why don't we execute this particular code once. Now I am going to show you the setup as such. So over here the thermistor is currently placed inside a hot water bath. This is the breadboard, Arduino Uno, and the LCD screen. So the resistance currently reads as 19 point, it's fluctuating between 19, so let me take it as 19.2 kilo ohm. And if I take a look at the mercury thermometer that I have over here, I can see that the temperature is currently 63 degrees, no, it's 64 degrees Celsius, 64 degrees Celsius. Now let me add a little bit of cold water to this so as to drop the temperature. Now as I drop the temperature, the resistance is going to go up. It is a negative temperature coefficient thermistor, so higher the temperature, lower the resistance value. So I have added some water, let me mix it up so that it comes to thermal equilibrium. Now on the thermometer I can read the temperature, and the temperature has now come to it's difficult to read. Yeah, it has now come to 52 degrees Celsius. Okay, so it is at 52 degrees Celsius, and the resistance, as you can read from the LCD screen, is 29.7 kilo ohms. Okay, let me add a little bit more water to this. This is a bit more of ice water. So we have dropped the temperature further. Now the thermometer reading now reads is, it is, just give me a minute, it is 45 degrees, it is 45 degrees Celsius, and the resistance is 36.1 kilo ohms. So the temperature is 45 degrees Celsius. I have to get the readings at a wide range of temperatures in order to make a plot between the resistance and the temperature. So I am adding some more water to this. So as I add the water, so the temperature has now gone to 39 degrees Celsius, and the resistance is 41.1 kilo ohm. Now let me move the thermometer to the ice water. So as I move it to the ice water, now you can see that the resistance is quite high now. So it is close to 60, it's still settling down, so let it equilibrate. The thermometer will also, the alcohol thermometer will also take some time to equilibrate, but currently I can see the alcohol thermometer reading is, just give me a minute, it's around 8 degrees Celsius, and it's around 8 degrees Celsius. The resistance is fluctuating quite a bit. We'll wait for it to settle down. Okay, I'm going to take the reading. So 8 degrees Celsius, I'll take it as 66.3 kilo ohm. I'll add some more water to this, so this will raise the temperature a little bit. So as I raise the temperature, it's interesting actually. I think because of the ice, possibly the temperature is currently at, just give me a second, it hasn't changed much actually. Alright, so I have sufficient number of readings now. So next what I'm going to do is I'll open a Google Sheet, and in the Google Sheet I'm going to enter the data of temperature versus resistance. So let me enter the data now. So at 8 degrees Celsius, the resistance in ohms is 66,300 ohms. At 22 degrees Celsius, it is 54,800 ohms. At 26 degrees Celsius, it is 50,200. At 39 degrees Celsius, it is 41,100. 45 degrees Celsius, it is 36,100. At 52 degrees Celsius, it is 29,700. At 64 degrees Celsius, it is 19,200, and at 81 degrees Celsius, it is 11,000. Alright, so I have these values. Now what I am going to do is, let me download this as a CSV file. Then I have written a Python code where I can upload this data. Alright, I have uploaded this data, and I have written a code where basically I read the temperature, convert it into Kelvin, I read the resistance values, and then I basically try to fit this particular equation. So this is referred to as Steinhart-Hart equation, where 1 by the temperature in Kelvin is parameter A plus parameter B into natural log of resistance plus parameter C into natural log of resistance to the power 3. So let's see how well this equation works for this data that we have, and extract the coefficients of the equation. I'm running this code. So I think there is a problem. I'll have to maybe first remove this, and then I'll have to upload it again. Run it now. Alright, so this is the data. This is the fit to the data. You can see it is not perfect, but I'm getting a mean absolute error in the prediction using this equation as 1.7 degrees. So I can expect to predict the temperature to within 1 to 2 degrees Celsius using the thermistor. Alright, so now what I will do is I will take the coefficients of this equation, and I have created another code where basically I can use these coefficients and then I can predict the temperature. So just give me a minute. So alright, so I have pasted the coefficients over here, and then now if I upload this code and if I go to this, so it should be able to predict the temperature correctly. So let's do one thing. So now I'll go back to this ice water where I expect the temperature to be close to 8 degrees Celsius. As you can see, the temperature is now correctly being predicted as around 9 degrees Celsius. It has slightly warmed up from the time we have done the experiment. Now if I put this into this water, the warm water, I can put the thermometer also just to check whether I am getting the correct reading or not. The water temperature now is being read as 36 degrees Celsius, and if I look from the thermometer, it is showing as close to 35 degrees Celsius. So as I told you, the prediction is accurate to within 1 to 2 degrees, so it is within that. So that's how you use the NTC thermistor to predict the temperature. So happy experiments.